Somewhere out there, right now, a radio wave carrying a piece of you is traveling through the dark at 670 million miles an hour, and it will not arrive for another 25 years or 43 years or 400 years. And by the time it gets there, you will already be gone. Your children will be gone, and maybe even your children's children will be gone. But the message will still be traveling, patient and silent, toward a planet you will never see. Hoping that something on the other end is listening. That is not science fiction. That is something that has actually happened. Human beings have physically transmitted messages toward real planets that we believe could support life, and today I am going to walk you through exactly which planets we targeted, exactly what we said, exactly how these signals were built, and exactly when, if ever, anyone out there will receive them. By the end of this, you are going to understand something most people never think about, which is that we have already reached out into the darkness, and the universe has not answered back yet, but it might someday, long after everyone alive today is dust. Let's start with the basic question, because it is the one that most people get wrong. When we say a planet is potentially habitable, we do not mean we have seen life there. We have not. Nobody has ever detected a confirmed sign of life beyond Earth. What we mean is something much narrower and much more careful. We mean the planet sits inside what astronomers call the habitable zone of its star, which is the range of distances where a rocky world could have liquid water on its surface if it has the right kind of atmosphere. Too close to the star and the water boils away. Too far and it freezes solid. It is often nicknamed the Goldilocks zone, not too hot, not too cold, just right. But even that is a simplification, because habitability depends on dozens of other factors too. The mass of the planet, whether it has a thick atmosphere or almost none, whether its star is calm or violently flares radiation across the system, whether the planet is tidally locked with one side permanently baking in daylight and the other frozen in eternal night. So when scientists build a list of potentially habitable exoplanets, they are really building a list of best guesses, planets that check enough of the boxes to be worth a closer look, and worth, as it turns out, an actual message. Now here is where the story gets interesting, because sending a message to another star system is not new. Humans have been doing this since 1974, when scientists at the Arecibo Observatory in Puerto Rico beamed a coded radio message toward a cluster of stars called M13, roughly 25,000 light-years away. That message contained numbers, the structure of DNA, a stick figure of a human being, a sketch of our solar system, and a picture of the telescope that sent it. It was more of a symbolic demonstration than a serious attempt at contact, because M13 is so far away that even if beings there received it and replied instantly, we would be waiting 50,000 years for the round trip. But it proved something important. It proved that humanity was capable, technologically and philosophically, of pointing a transmitter at the stars and saying, "We are here." Since then, the practice has grown into something called METI, which stands for Messaging Extraterrestrial Intelligence, and it is distinct from SETI, the Search for Extraterrestrial Intelligence. SETI listens. METI speaks. And METI has targeted real, nearby, potentially habitable worlds with real transmissions, using facilities like the RT-70 radar telescope in Yevpatoria, Crimea, and more recently smaller, but more focused efforts using powerful transmitters aimed at specific candidate planets discovered by missions like Kepler and TESS. This is the part of the story most people have never heard, so let's go planet by planet, and let's actually do the math on when these signals will arrive. Our first stop is the closest one, and it might surprise you how close it actually is. Proxima Centauri b orbits the star nearest to our own Sun, just over 4.2 light-years away. It is a rocky planet, likely a bit more massive than Earth, sitting in the habitable zone of a small red dwarf star. The problem is that Proxima Centauri is a flare star, meaning it periodically erupts with intense bursts of radiation that could strip away an atmosphere over time, so scientists debate whether anything could survive there long term. Even so, it remains one of the most tantalizing targets we have, simply because of proximity. A radio message sent toward Proxima Centauri b today, traveling at the speed of light, would arrive in just over 4 years. That is almost nothing on a cosmic scale. If hypothetically, an advanced civilization received it and replied within a day, we could have an answer in about 8.5 years. That is faster than some university degrees. It is the single most realistic candidate for anything resembling two-way contact within a human lifetime, which is exactly why it has been a priority target for message transmissions in recent years. Next, we move outward to one of the most famous planetary systems ever discovered, TRAPPIST-1, about 41 light-years from Earth. This is a small, cool red dwarf star with 7 Earth-sized planets packed tightly around it, and remarkably, 3 or 4 of them sit in or near the habitable zone. TRAPPIST-1e is often considered the best candidate of the bunch, roughly Earth size, likely rocky, and receiving about the same amount of energy from its star that Earth receives from the Sun. TRAPPIST-1f and TRAPPIST-1g are also in the running, slightly cooler but still plausible. A message sent to the TRAPPIST-1 system today would take about 41 years to arrive. Someone born this year would be in their 40s by the time that signal reaches its destination. If a reply came back immediately, we are looking at a round trip of roughly 82 years, meaning a person would need to send the message as a child and receive the answer, if they were lucky enough to live that long, somewhere in their early 80s. This is the boundary where interstellar communication stops being personal and starts being generational. Then there is Kepler 442b, a planet that keeps showing up on lists of the most Earth-like worlds ever found. It sits about 1,100 light-years away, orbiting a star cooler and dimmer than our Sun, and it receives about 2/3 of the energy Earth gets, but its slightly larger size means it may be able to hold onto a thicker atmosphere, which could compensate for that. A signal sent toward Kepler 442b today will not arrive until the year 3126. Read that again. Not next century, not in 1,000 years exactly, in 1,100 years. If we imagine sending that message now and somehow, impossibly, getting an instant reply, humanity would not hear back until roughly the year 4226. For context, that is further in the future from us than the fall of the Roman Empire is in the past, twice over. When we transmit toward planets like this, we are not sending a message to be answered. We are sending a message the way you might bury a time capsule, hoping some future version of civilization, human or otherwise, is still around to dig it up. Kepler 452b deserves its own mention, because for years it was nicknamed Earth's cousin in the media. It orbits a sun-like star about 1,800 light-years away, and its orbit and size are remarkably similar to Earth's, though its exact composition remains uncertain, since we cannot yet confirm whether it is rocky or a smaller gas world. A message sent there today arrives around the year 3836. That means if ancient Rome had somehow developed radio technology and pointed a transmitter at Kepler 452b, the day Julius Caesar was assassinated, that signal would only be arriving there around now, in our own present day. That is the scale we are dealing with when we talk about these more distant candidates. Gliese 667cc is another favorite among habitability researchers, part of a triple star system about 24 light-years from Earth, orbiting the smallest of the 3 stars, well inside its habitable zone. It's a super-Earth, meaning more massive than our planet but still likely rocky. A signal sent there today would take about 24 years, arriving sometime in the late 2040s, which puts it in a similar generational bracket to TRAPPIST-1, reachable within a human lifetime if we are patient. Ross 128b is worth including because its star, unlike many red dwarfs, is unusually quiet, without the violent flaring that plagues systems like Proxima Centauri. It sits about 11 light-years away, and a message sent there today would arrive in the year 2037, arriving faster than almost anything else on this list except Proxima b itself. Because its star behaves more gently, some researchers consider Ross 128 be a more stable long-term habitability candidate, even if it receives less attention in the headlines. TOI 700D, discovered by the TESS mission, orbits a small cool star about 101 light-years from Earth and is one of the first Earth-sized planets found in a habitable zone by that specific telescope. A signal sent today arrives in the year 2127, meaning it is a message not for us, but explicitly for whatever comes after us. A message we send knowing full well that we personally will never know if it was received. Now, once you have a list like this, real scientists and message-crafting teams face an enormous question. What do you actually say? Because unlike a text message to a friend, you cannot assume a shared language, shared biology, or even shared logic. Every message ever sent has leaned on mathematics and physics as the universal starting point, because the laws of physics should, in theory, be the same anywhere in the universe. The Arecibo message used binary code to represent numbers, atomic structures, and simple images built from a grid of pixels. Later efforts, like the cosmic call messages sent in 1999 and 2003, and the teen age message sent in 2001, expanded on this, including recordings of musical instruments, images of human faces, diagrams of DNA, and even Morse code-like signals meant to teach the recipient our counting systems before building up to more complex concepts. The philosophy behind all of these messages is the same. Start simple, assume nothing, and build a shared vocabulary of prime numbers, geometry, and basic chemistry before attempting anything resembling a sentence. This is also where the controversy comes in, because not everyone thinks sending these messages is a good idea. Stephen Hawking famously warned that announcing our location and technological capability to unknown civilizations could be dangerous, comparing it to indigenous peoples encountering technologically superior colonizers throughout history, an encounter that did not always go well for the less advanced party. On the other side, scientists like Alexander Zaitsev, who helped craft several of these interstellar messages, argued that any civilization capable of receiving and understanding an interstellar signal is almost certainly advanced enough that malicious intent seems unlikely, and that the scientific and philosophical value of trying to make contact outweighs the speculative risk. This debate has never been resolved, and it probably never will be, because it hinges on something we simply cannot know, which is what, if anything, is actually out there. What makes this entire subject so emotionally strange is the timescale involved. When you send a letter, you expect a reply within days or weeks. When you send an email, you expect a reply within hours. But when you send a radio message to Kepler 442b, you are participating in a conversation that will not be answered within your lifetime, your grandchildren's lifetime, or possibly within the lifetime of the human species as we currently know it. It forces you to think about communication not as an exchange, but as an offering, a message placed gently into the dark, sent not out of expectation, but out of hope, the same instinct that makes people write letters to be opened by future generations, except this letter is written in radio waves, moving at the fastest speed the universe allows, toward a handful of specific coordinates in the sky where we have calculated, with real telescopes and real data, that conditions might just be right for someone to be listening. And that is really the heart of this whole story. We are not guessing randomly into empty space. We are choosing our targets deliberately, planet by planet, based on measured distances from stars, measured sizes, measured temperatures, and educated calculations about atmospheres. We are then translating those coordinates into transmission windows, calculating exactly how long a photon would need to travel from a dish on Earth to a specific point in the sky, and sending organized, structured information along that path, information built to be as understandable as possible to a mind that might not share a single one of our senses, our chemistry, or our history. Every message is a bet that math is universal, that curiosity is universal, and that somewhere among the billions of planets in our galaxy alone, there might be another civilization capable of catching what we are throwing, and importantly, motivated enough to throw something back. So when you look up at the night sky tonight, understand that some of those points of light are not just distant suns. A few of them are addresses, real, calculated, targeted addresses, where a piece of human curiosity is already traveling, decade after decade, century after century, carrying the strange, hopeful signature of a species that looked at the impossible scale of the universe and decided to say hello anyway. We may never hear back. We may not be around when the answer, if it exists, finally arrives. But the messages are out there right now, crossing the dark between the stars, and that alone tells you something remarkable about who we are as a species, that even facing odds this long and timescales this vast, we still choose to reach out. If this kind of question keeps you up at night the way it does me, make sure you are subscribed, because we are going deeper into the search for life beyond Earth in upcoming videos, and you will not want to miss where this goes next.